The Mst Centerseal high-pressure rotary feeder valve, or RFV, is an evolutionary leap forward in the design of the time-tested taper plug-style Bauer rotary feeder valve. Using a patented computer analysis and design process, the Mst Bauer Centerseal provides a sophisticated yet elegant solution to the historical issue of bore deformation and the typical use of an offset rotor. The latter was historically used to compensate for heat-up cycle shape change of the bore axis versus the rotor axis that occurs when the unit is heated from a cold ambient state to thermal equilibrium. The Mst Centerseal technology results in a dramatically reduced break-in cycle, which is required to lap the rotor into the body until a fully round fit is created. The patented Centerseal design results in a correspondingly longer product lifespan. To better understand how this works, let's take a brief look at a theoretical conventional Bauer RFV when no centerline offset is used, paying specific attention to how the valve body bore and rotor seal is attained while the unit is being heated to its operating temperature, metallurgically speaking, an approximate 8-hour cycle. At ambient room temperature, as historically processed in the shop, notice that both the rotor and bore are true round, exhibiting a complete seal between the two that should ideally exist once they are heated to normal operating temperature. Notice, however, what happens if a unit is heated based on not providing room temperature, lift and shape change compensation as part of the normal startup cycle to maximum rated pressure. Steam begins the heat-up process from the underlying vessel. Because of the aspiration mechanisms of the HPRFV, or high-pressure rotary feeder valve, there are essentially two thermal zones that exist, with the lower of these zones rising to a relatively higher temperature, and hence greater centerline thermal lift and growth of the lower portion of the bore. Predictably, the initial room temperature round bore shape at time 0 reforms to an O-Brown-like elliptical shape due to the 8-hour thermal expansion cycle. The rotor remains round because it is heated uniformly over the vessel heat source, analogous to a barbecue spit effect. The historical generic Bauer RFV compensated for this effect by pre-offsetting the rotor down, using eccentrics around the bearings so that the lower half would fit the lower bore first. Let's go back and take a look at a lateral view of the unit over the same heat-up and break-in period. Notice that as the RFV becomes hot and undergoes thermal change, the rotor needs to be advanced to maintain the taper part of the seal system. Note that if the rotor centerline axis were not offset down at ambient status, the advancing rotor would hit at the top of the now O-Brown-like body bore. Left unchecked, this would result in no seal at the bottom, the side against the steam pressure. Because the rotor has a taper, and the original goal was to prevent metal-to-metal contact at the top of the bore, an offset to counter the axis lift was used. One problem with this solution is, in order to drop the rotor enough to match the thermal axis lift, the rotor must be shifted back to create the space for the lift dimension. Then the rotor can be shifted down, so the unit starts off with the rotor fitting the lower bore. Furthermore, when the rotor is eccentrically shifted down to allow initial contact at the bottom, the result is a doubling of the clearance at the top, leaving room for leakage until the rotor can be forced in axially. A full round fit does not take place until the rotor wears away enough bore in the bottom quadrants until a full round fit is effected, an outdated break-in cycle. The Mst Centerseal, by design, eliminates the need for this obsolete break-in process between the rotor and bore. Let's take a look and see how. From its inception, the Centerseal takes into account the natural thermal body bore shape change that occurs as the valve heats up. Unlike the traditional Bauer RFV offset method, the Centerseal bore is purposely pre-shaped in a quasi-elliptical O-Brown form in its ambient cold state. As the RFV heats up, the patented design allows the bore to naturally morph into an efficient round shape for a near-perfect mating with the rotor and body bore in both circumferential and taper fit. In essence, this thermal equilibrium state becomes the natural shape of the RFV. The result is a much truer and more efficient seal between the RFV and the rotor, and by design, eliminates the need for the longer break-in process and machine lapping of the historical method, as well as its associated loss of axial range.